Is this recording? I think it is. So it's this is for Todor and anybody else who may need it. And so this is statistics, actually, class. This is Unit 5 probability, Lesson 3, Venn diagrams, unions, and intersections notes. So Venn diagrams, unions, and intersections. I'm showing a picture of a Venn diagram here. So you have this very often you have this box. Let me do this here, okay, which is called like the universe. Like nothing exists outside of this box. That's everything inside this box. And you have some circles. It can be 2, it can be 3, and it can be like touching and non-touching. If they're touching, we say this is intersecting. This is the intersection in the middle. This is where both A and B happen because it's part of the A circle and it's part of the B circle. So we can represent things happening with these boxes and these Venn circles. And this whole thing is called the sample space. Sample space is everything. So the probability that something's inside this rectangle is 100%, or 1, as we'd say in probability, 1.0. The whole thing. Nothing else is possible. Okay? The circles themselves represent the probability of each event. Like it's 2 things that can happen here, the A thing and the B thing. We'll do a word problem in a second. So the union is when we have the probability that either thing happens. And the symbol is a big U, like that. That's called a union. You can make little tops like I did if you want. It's probability that either thing happens. So you shade in both of the things. You shade in the first one and the second one. You'll see in a second. Okay, and the intersection in the middle part here is the probability that both things will happen. Okay, and the symbol for that one is and. It kind of looks like an A. You could think about it like that, but you don't want that crossbar. Okay, so that's an A. That's the and. Now, if we look at these 4 pictures, we should be able to match these boxes with one of the pictures. So first one I might look at is the first picture that has these both A and the B circles shaded in. Probability that both A and B happen? No. Probability that either A happens, all of A, or the probability that B happens. So this would be the correct one. You might have guessed this is where both A and B happen, in the middle, in the intersection. The C, remember, means not. So the probability that A does not happen, you may have guessed, is where A isn't shaded. And this is the probability that A doesn't happen, and also the probability that B doesn't happen. Okay? So when we look at these, we can ask ourselves to shade these probabilities. So shade A and not B. So we don't want to do all of the A circle, because we shade all of the A circle, that's got part of the B circle in it. And we want to make sure that we don't have the B circle. So one thing we can do, if we get confused, is we can do the first one first, the A, change colors, and say we want where we have not B, everywhere where there's not B. Okay? Everywhere where there's not B would be everywhere except for the B circle. Now you don't have to do this. This can get a little messy. Whoops. Shade, 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 shade. So this can get a little messy, but what we want is where both of those are shaded, the A and the not B. And as you may have guessed, that exact thing happens to be A and not B. That part right there. So in effect, we could erase all the other stuff except for what's right there. That is what we want. That is A and not B. And how about not A or B? Not A is, not A is outside of the A. Or the B circle. So we need to shade all of the B circle now. Well, part of it's already shaded here. Okay. That is not A or B. Okay. Not A, again, not A is out here. And everywhere in the B circle that isn't in the A circle, not A. Or not B. Let's find where not B is. Not B is everywhere that's not in the B circle. So I believe there we are. We've shaded not A or not B. So if something happens anywhere in those shaded spaces, that is the correct representation. In your statistics class, you are interested in exploring the taste preference of your classmates. You have two tastes, sweet and salty. 25 students were asked if they prefer both. So 25 students in the survey total. Total is always over here in the table, bottom right, okay, in these two-way tables we learned about. We asked if they prefer both, salty and sweet, only salty, or neither one. And so we have these totals of sweet and no sweet. We have these totals of salty and no salty, right? And so, yeah, let's take a look at this. I think we can do it inside the Venn diagram. So let's call A our sweet, and you can, if you want to, kind of sweet, salty. You can do that if you'd like, if it helps you. So let's see. It's always good. It's a very good idea to do the middle first. It's a good habit. So let's do the intersection first. So that would be yes, sweet, and yes, salty, right? Where is that? How many people? Looking at yes, sweet, yes, salty, 6 out of 25. So 6 would be in the center of yes, sweet, yes, salty. Okay? And then we can think about just the sweet but not salty. Sweet but not salty. So yes, sweet, no salt. And I think that's 11. The intersection of yes, sweet, and no salt is 11. Okay, that would be right here. Yes, sweet, no salt. And we have, I'm going to undo that and say that's the 11 that we talked about. Okay, let's pause this video. We'll do a second video for the other thing.